Now for problem number 10. The regular hexagon affords us much convenience. Each angle at the center is 1/6 of the revolution because there are 6 equal angles at the center. And we are trying to find the angle AOB. And if we have one of 1, 2, 3, 4, 5, 6, so this is 1 out of 6, which is 1/6 of 360. So we have AOB, that angle is 360 divided by 6, turns out to be 60 degrees. And not wanting to forget, we will put that in there. We will put that in there at the appropriate time. The area of the hexagon is 6 times the area of one of the equal triangles. So we have 6 equal triangles, and the area of the entire thing is 6 times the area of each triangle. The area of one may be determined by considering that the length of each line from the center is 5 centimeters. So each one is 5 centimeters. And recall that the angle AOB is 60 degrees. What do we do? The area of any triangle may be found by taking half of the product of any two sides and by also multiplying by the sine of the angle that the two sides form. This method may be applied because we have two sides of the triangle and the angle that the two sides form. So the area of each triangle is what? Half the product of the two sides, 5 times 5, because 5, this side is 5 and this side is 5. This side is 5. So multiply that by sine of the angle that the two sides form, sine 60, and that is what we will get. A half 5 times 5, sine 60. Do not forget that we have 6 of them. So that turns out to be 75 times 0.866, and that gives about 65 centimeters squared. Recall also that we need to find the area of the hexagon that consists of 6 of those triangles. So we find the area of one triangle and we multiply that by 6. We do it in the same step. Multiply 6 by the area of each triangle, and we will get the entire thing. And that's all there is to it. But we have a lot more to 10, part B. The angle of elevation of P from K is 28 degrees. The angle is therefore located at K. Also, any line on horizontal plane is perpendicular to a vertical pole. For example, PK is on horizontal ground. It must be perpendicular to that pole, PL, or we may call it LP. So that should be a right angle, as it is required of us in the statement of the problem to include one right angle in the diagram. At least one of them, because we have more than one. We have another one over here. So we are saying this is supposed to be a 3-dimensional figure. And K, P, M are points on horizontal ground. And we have a vertical pole here. So where K, P meets this pole has to be a right angle. And also this one must be a right angle. But we're just making use of just one of them. So this is a right angle. All of these lines, these 3 lines, are on horizontal ground, and this is a vertical pole. Any line like this on the ground that meets the pole will therefore be a right angle, because vertical and horizontal meet at right angle. And let us include also that 28 degrees angle. We need to find LP, and KP is 15 meters. Put in that 15 meters. We need to find LP or PL. This one we need to find, and this is 15 meters, and this is a right angle triangle. The line KP is on a horizontal plane and the flagpole LP is vertical. Horizontal and vertical are perpendicular. That makes triangle KLP a right-angled triangle. So there we have the right-angled triangle. LP is opposite to the known angle, and the known side is adjacent to that known angle. We have opposite and adjacent. Let us apply the tangent trig ratio. We have opposite and we have adjacent. We need to find this. This one is opposite to this angle. This one is adjacent. Opposite and adjacent is tangent. And tangent is equal to opposite over adjacent. And what is the opposite? LP. And what is the adjacent? 15. Or PL. LP is the same thing. So PL over 15 is equal to tan 28. Eliminating this 15 by multiplication, because we're dividing by 15. Eliminate it by multiplication. So we have make LP the subject of the formula by multiplying by 15 on the right hand side. So PL is 15 tan 28. We expect it to be a bit around about half or so. So no doubt about 14 so. Well, half of 15 is about 7.5, so around about 8. So 8 meters. So 8 meters. We retain the one place of decimal because each answer in this section is required to be written to 2 significant figures. So we write that as 8.0 meters because we need 2 significant figures. So we need to throw in another figure there. So we are retaining that single decimal place in order to complete the number of significant figures that are required in the statement of the problem. Find Km. That is what we are finding now, Km. Find Km by making use of triangle KLM. There is nothing that tells us that KLM is right angled. We need also LM is equal to 19. Put that in. 19 meters for LM. And we need to find Km. And the triangle is not right angled. Cannot be right angled. Impossible to be right angled because this angle is greater than 90. So the other two will have to have a sum that is less than 90 because 90 plus 90 is 180. The number that is required for the sum of angles in a triangle. So if this is 115, then these two must be less. Each one must be less than 90. Well, as a matter of fact, if we take 115 from 180, that is less than 90. Therefore, these two angles each must be less than 90. It cannot be a right angle triangle. Cannot say sine is equal to opposite over hypotenuse, nor for cosine, nor for tangent, nor can we use Pythagoras theorem. We therefore make use of the rule that is applicable to or in the circumstance that we have two sides of a triangle and the angle that the two sides form. We will make use of the cosine rule that pertains to two sides of a triangle and the angle that they form. So the cosine rule says that the one opposite to the angle is equal to this one squared plus this one squared minus 2 times this cosine of the angle that the two sides form. And right here, CSEC, well, I don't think that they set a trap. It's just that they need the students to be aware that the cosine of an obtuse angle is negative. Therefore, we will have a negative value here to multiply by a negative value here, which will be positive. So we will have all positive terms here. After finding that nice sum, then we know that Km will be the square root of 827, and that is equal to about 29 meters. Triangle LMP is also right angled, and PL was calculated to be 8 centimeters. So there we have triangle LMP, which is this one, LMP. We know that it is right angled because this line, as we stated before, is also on a horizontal plane, and this is a vertical pole. Horizontal meets vertical at 90 degrees, so this triangle is also right angled, and we need to determine the angle of elevation of P from M. So the angle of elevation of P from M is the angle at M because it is taken from M. TF is equal to 8 meters is opposite to the angle, and ML is 19 centimeters. So ML is 19 centimeters, and here we have 8. ML is 19 meters, and here we have 8 meters. What do we have? Relative to this angle, we have two sides. This one is opposite to the angle, and this one is adjacent. Opposite and adjacent implies tangent, and of course, tangent is equal to opposite over adjacent. 8 over 19, which is equal to 0.421, and M is equal to tan inverse 0.421, which is, if we are saying that the tangent of the angle is 0.421, and we need to find the angle, we need to go in the opposite direction of taking the tangent, which is taking the tan inverse, or the reverse of taking the tangent. And that, we have the tan inverse of 0.421, and that turns out to be 23 degrees.